We'll have a look at the FPGA board, Xilinx Digilant Spartan 3E board with the 500 version FPGA Spartan 3E, which if I start it up, runs the Eco32 processor, keyboard connected. There's no computer attached except through a serial interface. There's a monitor built in the ROM. Where you can mess with the memory, examine programs, even unassembled programs. And in this case, we're going to load the program I made. But before that, I program in the adapted eco design, which has an I/O module, input-output module. Where it's a bit small. Mainly there is provisions for putting data in and out to the DA converter module, which is a known module which I've used, and it's just 20,000 times per second writes the output of a program, a C program, to the DA converter. And C program can set a register, an input-output register, which then gets put on the DA converter, and there's a C program which uses that adapted design, which talks with the DA converter, as it were. I program that in the hardware by doing this. Now I get an error on the display because the switches, which are here on the board, they're set wrong. This switch doesn't allow the design to be loaded properly, so I have to reset it. This button, now it comes up with monitor 1.2, and I type the load command, and I use the other machine, which is connected, to set up the file which comes from the make of that program, .exr. Waiting for client, and then I type on the keyboard here connected with the FPGA. Type the load 0 command, and it will run and take the Intel or Motorola formatted binary. It'll view you and call it hexadecimal. It does anyway somehow transfer over the serial port right there from the computer with the serial port. It serves the program as a binary file to the eco processor. Then I can type C to start the program, And we have a meter connected. So I give a value which goes to the DA converter. Let's start with the highest value, 4096. And let's pay attention to the multimeter. Connect the digital meter to the output pin of the FPGA board here. At the moment it says 0 volts. I switch on the necessary switch, press enter. And of course I did it wrong. The good viewers have understood what I was going wrong. Well, the program says I first put the full value of the DA converter on for a number of seconds. In those seconds it's computing the addition of numbers adding themselves. I suppose it's a type of Fibonacci limit number or something, but it doesn't matter. It's just 3 million adds, and that's the results. The results are correct, so the computer and the C compiler and the program loading in all work correct if I test it on the host. Remember, this all runs only on this FPGA here, with the memory here. This is the dynamic memory, 64 megabyte, and down here is the flash memory, 8 megabytes flash memory. And see, I filled in the value 4096, which in 12 bits is perfectly 0, so we got the 0 volts from the DA converter. Now I do 4095, and we watch the meter. So first full value for 3 seconds, and then of course still full value. Now we'll take half the value of the maximum number of the DA converter's range, 2048. And we can say half the voltage.